Hello, I'm going to talk about object storage, a typical system design interview question. An object storage is something which stores typically larger objects by some key. One good example is S3 from AWS. So let's see how we can design this. Some topics I would cover is clarifying questions and requirements. As always, it's pretty important, and usually like 5 to 10 minutes of the interview needs to be spent on those. And then I'm gonna cover storing metadata and raw data. Then I'm gonna touch base on storing raw data in chunks. And then a couple more topics like multiple version support, list operation support, and erasure coding. If you don't know what some of those are, don't worry, I'm gonna cover that when we get there. So some clarifying questions. What are the objects and keys we store? Scalars, vectors, and structured data. I don't know, maybe if it's like scalars, maybe it's just not even object storage question after all. And in some cases, maybe just key value store would be better. But most likely you're gonna end up with some sort of unstructured data. Then another one, what's the maximum object size? It's also pretty important because it's can be quite different if it's like 1 kilobyte versus gigabyte or like terabyte. Like kilobyte is just like can probably come up with a simplified system, whereas for like 1 terabyte you may typically need to like chunk the data almost certainly. And then you may also want to ask what are supported operations on the objects. Is it like create, read, update, and delete? Or is it we support list, or are there some more operations? It's all pretty important because it may define how we like store the data. Also, going slightly ahead, most likely if you want to support something more than CRUD, you most likely need some separate indexes and separate data structures for that. Another one, do we support multiple versions and restoring deleted objects? Then, and assuming we need high durability, what are the availability consistency requirements? Make sure to ask all of these questions and get on the same page with the interviewer about what's needed. Then let's get to storing metadata raw data. It's probably like a key idea of this system design interview question, because metadata is like something we would need to like reference the raw data, and it's handled separately, and it's like it's a concept which like simplifies this question quite a lot. And so metadata would include some information about size, location, version history, and more. Basically, all we need to do like operations on the object, and typically it's going to be much smaller than the raw data we store. And metadata would typically be stored in some strongly consistent system, maybe some system which uses like Paxos or like Raft algorithm, because you really want to have same overview of like what the state is for like different clients. Otherwise you can get like data corruption and all like nasty side effects. Raw data needs to be usually stored in a very scalable way. We're usually not going to even use a database, but use something like a write ahead log, where essentially we write data on disk in a sequential manner. And then metadata is required to access the raw data, and basically like without the metadata, raw data is kind of like mostly useless because it just like, seems like an arbitrary blob or arbitrary binary data. For example, it can be soft deleted by removing the metadata, and then later when we do some defragmentation or some like cleanup, we can delete that. So overall, this structure is something similar to what is done by operating system when like working with a disk and storing files. So there would typically be some like metadata information as well. And overall, the file sizes themselves can be arbitrarily large, or well, maybe not arbitrarily, but like can be very big. And also another property is like the range can be pretty big. It can be like small files up to like maybe gigabytes or maybe multi-gigabyte size of files. So let's cover about chunking. So if the values can be pretty large, it can be more efficient to store them in like some blocks essentially. So each chunk would have its own metadata entry and can be stored separately. So it's gonna make it like easier to operate with, easier to move around, and then it's also like makes sure we can utilize the space better. So, and basically from perspective of raw storage part, each chunk is pretty much a separate value. So raw storage doesn't know about it, it just stores this block as it is. And overall, chunking can be beneficial. It can reduce fragmentation, improve storage utilization. So that's where like it pretty much depends of like what the maximum size. I think like if it's probably something around like 1 megabyte or less, you most likely don't need to worry about chunking. But with 1 gigabyte, for example, it can be more beneficial. Like there can be other like advantages, like for example, when you do like upload and store, if you can like do some partial operations and which succeed and like some small one fails, then it's much easier to retry like one small chunk upload than to like retry the whole thing. Another topic I'm gonna cover is multiple version support. It's something that usually it's not offered like by default, but usually like systems like S3 may support like enabling it. And then like it can also be handled on metadata layer. Essentially each version of the object corresponds to its own like metadata and essentially can be considered a separate object. You just have an abstraction on top of this which tells how to like kind of combine it together. For example, client can pass which specific version they want, or may just pass, okay, give me the latest version, or so on. And deletion can be done in a soft way by adding some flag also, is like possible recovery later is important. And soft deleted objects can be excluded from the fragmentation cleanup until like maybe they're like fully deleted. Also, if the data between versions is only slightly different, it may be beneficial to reuse it, like some blocks between versions. So typically it's gonna be hard to do for unstructured data because oftentimes you would see like small bits of differences in random places rather than like specific blocks being different. But depending on the use case, again, like it depends on what clarifying questions with the interviewer yield. This may be something to consider. Then let's go over like list operation support, since it's like one which is can be commonly happening. It usually requires separate indexes in addition to what's used for CRUD operations, and usually can be like slower than CRUD ones. And then also if the QPS of CRUD operations is pretty high, we may have to sacrifice some consistency and freshness of data and get like maybe slightly like older results of the list. Because imagine like you can start like iterating or like returning some value and then like some updates happen. You don't want to just like grab a lock on like a ton of values in your like storage just so you can return a list. So again, all of this is like important to clarify during requirements or like as you go. For example, one case we can use some form of prefix tree if the keys are structured as file paths. But even then, like we probably cannot do arbitrary subpath match, but maybe we can do something like take a full word in the path, like between slashes, for instance, and try to search by that. So effectively, like saying something like, "Hey, let's list everything in this folder," even though typically folder is not like a natively supported concept for these storages. Otherwise, like it can be just prohibitively expensive to support and quickly go into like a full scan territory. It's going to be extremely slow. And let's talk about erasure coding. So a typical way to achieve high durability is to have a lot of replicas for the full data. It doesn't sacrifice CRUD operations performance as well, which is very nice, but it results in sizable extra cost. Because like you may probably want to have like 4 or 5 replicas to achieve like a lot of nines of durability, which is going to be satisfactory for like a no data loss requirement or almost no data loss requirement. Um, so erasure coding is a technique which allows to do much less extra space for even high durability at the cost of more expensive CRUD operations. To give a simplified example, like suppose we want to add a little bit of redundancy, and the goal is to like save some like data in cases like maybe like one bit of data gets corrupted. Suppose we have integers x1, x2, so on, xn. If one of the numbers gets lost and it cannot be queried, we would just normally lose part of the data, and it's not good. Now let's introduce xn plus 1, which is x1 XOR x2 and so on XOR xn bitwise. So this number, if you store it, it adds 1 divided by n factor of extra storage, but allows to recover any of the n lost parts of data. So, which is pretty nice. And we can do a more sophisticated math with like some like sums or subtractions of some like integers with coefficients. I'm not gonna put it here. It's also probably not as important for the interview to know specific like numbers, but the idea is like you can get a lot of nines of durability with only like 50% of extra storage, which is extremely good. And to the best of my knowledge, S3 uses something like that. So yeah, but yeah, like your read operation would be a bit slower because now you need to recover all the pieces and put them together, and that's like a bit slower than just doing a pointed read. But given that like cost is going to be much lower, and typically like for like object storage you don't need the performance of key value store, this is going to be totally acceptable. Cool, thanks for watching.